Welcome to the lesson K.C.S.E paper 1 2007. The question is about calculus, finding the gradient of the tangent and getting the gradient. So the question reads, the gradient of the tangent to the curve y is equals to ax cubed plus bx at point 1, 1 is negative 5. Find the values of a and b. So I'm going to begin by sketching this curve. This is the curve, it's the sketch, and then I will also draw the tangent to that curve. So this is the curve, and then this is the tangent. This is the point, and the point is common to the tangent and to the curve, and that point is 1, 1. Now you're given the gradient of the tangent, this tangent to the curve at this point is negative 5. Find the values of a and b. So the first thing you're going to do is to get the gradient of this curve at this point, which will also be the gradient of the tangent. So the gradient of the tangent to this curve at this point will be obtained by differentiating the function of that curve at that point. So if we take the function of this curve, which is y is equals to ax cubed plus bx, if you want to get the gradient of this tangent at this point of the curve, we shall differentiate these. So gradient will be obtained by differentiating this function with respect to x. So this is how we do it. We'll differentiate this one with respect to x, dy over dx. This one is given by differentiate this function, so you get 3ax squared plus b. So that is the gradient function, and this is what is going to give us the gradient of the tangent at this point on the curve. Now this gradient, because now this represents a gradient, that represents the gradient, we've already given the gradient is negative 5. So therefore we say 3ax squared plus b is equals to negative 5. Now when you look at this equation, there's something else that we can obtain comfortably, and knowing that definitely if this point on the curve 1, 1, look at this point, this is 1, 1, this is 1, 1, the point is 1, 1. So at this point, at point 1, 1, which is this point that is here, as you can see, this point that is here, the value of x at this point, the value of x at this point is 1, the value of y is 1. So we don't need the value of y, because in this function we don't have y, the value of y, so we only have x. So at x is equals to 1, just substitute here. So 3a, and then x is 1, so 1 squared, and then plus b is equals to negative 5. So we're just substituting x. This will give 3a plus b is equals to negative 5. Now this will give us the first equation. That equation alone cannot give us the values of a and b because it has two unknowns. So we need to think again from this function here, what else are we going to use in order to get another equation with a and b, and that equation gonna give us the values of a and b if we combine with the second equation or the first equation. So we can use the function of the curve, this function of the curve at this point, because this point on the curve is, we're given the point on the curve which is 1, 1. So we're going to consider the function of the curve, which is y is equals to ax squared plus bx. Then at point 1, 1, and this point 1, 1 means that x is equals to 1 and y is equals to 1. So this is x, this is y. If we substitute these values of x and y in this function, we shall remain with a and b. That will help us. So that is y is equals to 1, then a, then x is equals to 1 again, this is 3, then plus b, then 1. So we're just substituting, so this will give 1 is equals to a plus b. Now this is giving us the second equation. Now we have two equations. The first equation was here, 3a plus b is equals to negative 5. So 3a plus b is equals to negative 5. This is the first equation. So we are going to solve these two equations. These are simultaneous equations. We solve them using any suitable method. I prefer to use the elimination method, and that is what is going to give us the values of a and b. So to eliminate b, you subtract, because you can see b is uniform. So 1 subtract negative 5, this will give 6, and then this a subtract negative 3a will give negative 2a, then b will disappear. So in this part a will be negative 3. So if we substitute negative 3, if we have the first equation as a plus b is equals to 1, this one is equals to a plus b. So when a is equals to negative 3, b, we substitute here, b will be given by 4, and therefore the values of a and b have been obtained. So a is equals to negative 3 and b is equals to 4. So that is basically how you're supposed to solve that question.